Welcome to solverfy.
So in this problem, we have to find out the empirical formula of few compounds we are given with. So and there are few rules to find out the empirical formula of a compound from the percentage of its elements. So these are the rules. So first rule here is we assume that the compound has a mass of 100 gram, and in that case the percent of each element will turn into the mass of each element, and from those masses we will find out the number of moles of each element. And as we know that the number of moles of an element is simply the mass over its molar mass. And while using the molar mass or atomic mass, four significant figures are used to match the precision of the experimental masses. And then finally, the simplest whole number ratio of those number of moles are uh, calculated by simply dividing each number of moles by the smallest number of mole. So that means that we will divide each number of moles calculated by the smallest number of moles to find a smallest, the simplest whole number ratio of the number of moles, and from this simplest ratio we can easily find out the empirical formula of the compound. So let's start with this first problem here. So here we have 55.3% K, 14.6% P, and then 30.1% O. So first you have to make sure that the total of these three is 100%. And if we just sum this three up, we will see that the total is 100%. That means there is no other element in this compound. So as we have said that according to the first rule, we will consider the total mass as 100 gram. That means this percentage values will turn into gram mass values. So that means we have 55.3 gram K, 14.6 gram P, and 30.1 gram O. So from these values, we can find out the number of moles of each element present. So moles of K, or the potassium, will be equal to 55.3 gram over the molar mass of potassium, which is 39.10 gram per mole, and this will give us a value of 1.41 mole. And similarly, we can find out the moles of P, or phosphorus. So phosphorus has a value of 14.6 gram, and the molar mass of phosphorus is 30.97. So this will give us a value of 0.471 mole. Same way you can find the number of moles of oxygen. So the mass of oxygen here is 30.1 gram, and the molar mass of oxygen is 16.0 gram per mole. This will give us a value of 1.88 mole. So now using the second rule, what we'll do is we will divide each number of moles by the smallest number of moles to find the simplest ratio of the elements. So from here we can see that the smallest number is this, so we will divide each number of moles by this 0.471, which will give us a ratio of the elements present in the compound. So the ratio of K will be 1.41 mole over 0.471 mole. which will give us a value of 2.99, and since it is very close to 3, we can write it as 3. Then for phosphorus, the ratio will be 0.471 mole over 0.471 mole, give us a value of 1. And then for oxygen, the ratio will be 1.88 mole over 0.471 mole, and this will give us a value of 3.99, and which we can write as 4. So the ratio of potassium, phosphorus, and oxygen here are 3 is to 1 is to 4. So the empirical formula for this compound will be K3PO4. So this is the empirical formula for this compound. Now in the second part of this problem, we have 25% sodium, 14.9% silicon, and 60.6% fluorine. So again, we'll consider each percentage as gram, and then we'll calculate the number of moles for each atom or element. So for sodium, it will be 24.5 gram over sodium's molar mass, which is 22.99 gram per mole, give us a value of 1.06 mole. Then we'll find out number of moles of silicon. So the mass of silicon here is 14.9 gram, and we have silicon's molar mass, which is 28.08 gram per mole, and this will give us a value of 0.53 mole. 19 gram per mole, and this will give us a value of 3.19 mole. Now we will divide each number of moles by the smallest number, which is 0.53. So that will give us the ratio of each element. The ratio of sodium will be 1.06 over 0.53, which is a round figure of 2. Then for silicon, it will be 0.53 over 0.53, which will give us 1. And for fluorine, it will be 3.19 over 0.53, give us a value of 6.02, or making it approximately 6. So the ratio here is 2 is to 1 is to 6, and that means the empirical formula will be Na2SiF6. So this is the empirical formula for the compound. Now in the third part, we are given percentage of carbon, hydrogen, nitrogen, and we are said that the rest or the remainder is oxygen. So if we subtract the total from 100, 62.1 plus 5.21 plus 12.1, we will find that the rest is 20.53. So this is the percentage of oxygen. And now again we will just simply count each percentage as mass in gram, and we will find the number of moles for each element. So moles for carbon will be 62.1 gram over carbon's molar mass, which is 12.01. It will give us a value of 5.017 mole. And then for nitrogen, it will be 12.1, since that is the percent is 12.1 over nitrogen's molar mass, which is 14.00, and it will give us a value of 0.86 mole. Zero point 0.86 mole. Then for hydrogen, the mass is 5.21 and the molar mass is 1.008 gram per mole, and this will give us a value of 5.17 mole. And for oxygen, the mass is 20.53 over oxygen's molar mass, which is 16.0 gram per mole, and this will give us a value of 1.28 mole. So, and now among these four number of moles, we can see that 0.86 is the smallest. Now we'll divide each value by 0.86 to get the simplest ratio. So the ratio of carbon will be 5.17 over 0.86. This will give us a value of 6.01, and we can write it 6. Then for hydrogen, it will be again same 5.17 over 0.86, which is 6.01 or approximately 6. Then for nitrogen, it will be 0.86 over 0.86, which will be 1. And for oxygen, it will be 1.28 over 0.86. It will give us a value of 1.5. So now we can see that we have got three approximate round figures, but in this case it is just halfway through 1 and 2. That means we cannot round it to 1 or 2. So to make it a round figure, the smallest round figure we can make from is 3, and for that we have to multiply this by 2. To multiplying it by 2, we can get 3, but in that case we'll have to multiply each number by 2. So we'll multiply this 6 by 2 to get 12. 6 6 multiplied by 2 will give us 12, and for nitrogen it will be 1 times 2 equal to 2. So the ratio of carbon, hydrogen, nitrogen, oxygen here is 12 is to 12 is to 2 is to 3, and that means the empirical formula will be C12H12N2O3. So this is the empirical formula for that compound.